Hello students, I am Chakraborty from Department of Geology, University of Delhi. Today in this module, our aim is to discuss the composition of petroleum. That is, what are the compounds that basically make the oil or gas. And once you go through this module, you will be able to know the different kind of compounds that make the hydrocarbon, their very nature, how we differentiate these different kind of compounds. We also will be able to understand that what kind of organic matter that basically under its maturation result in different kind of hydrocarbon molecules. And also we will discuss that what we call about the maturation of the hydrocarbon and when that kind of hydrocarbon, that is oil, that is produced. You will also be able to understand the different kind of controls that basically is involved in the making of the oil. So once we discuss that what really is petroleum and what we mean by oil. It is petroleum by itself, the name, it means the rock oil, and that means the oil that remains within the rock. Essentially it is the compounds, that is the hydrocarbon compounds which make the oil or petroleum, and the main constituent elements are the carbon and hydrogen. And if we see the hydrogen is to carbon ratio, the average hydrogen is to carbon ratio, it is about 1.85. So that means that more of hydrogen than carbon, then it is the basic composition of petroleum. Though there are some reports of some inorganic origin of the petroleum that is there, particularly involving with the igneous rocks, but in majority of the petroleum occurrence, and that people, the majority of the scientists, they believed about the organic origin of the petroleum. That means it is the organic matter that by its maturation that gives rise to the petroleum. So the organic origin of the petroleum, that basically is reflected in the different kinds of organic compounds that we find within the composition of the oil or gas. We will discuss that what are the basic compounds that we get in the oil or gas. Now once we talk about hydrocarbon, that what state of matter that basically we get the hydrocarbon. We get the hydrocarbon in all three states, that is the gaseous form, the liquid form and the solid form. In the gaseous form, what we get, the mostly the carbon number 1 to 4, those basically happens in the gaseous form. We get the different kind of gaseous form, that you get the swampy gas, you get the shale gas, you get coal bed methane. So all these are examples of the different gaseous form of hydrocarbon. Now we get this liquid form, mostly the carbon number 5 to 17, that basically belong to the liquid form, and this also includes the light hydrocarbon, the heavy hydrocarbon and the condensates. What are condensates? That remain in the gaseous form in the subsurface, but if you bring it to the surface, that turn into liquid form. That is what we call the condensates. Besides this, we can have the solid form also, the tar sands, the asphaltenes, the different kinds of albertite, the grahamite, all these, they are basically the solid form, and these solid forms also we get in form of the tar sands or the oil sand and the oil shale. So all these different forms of this hydrocarbon that we get in nature. Now we will come on to the basic constitution of the oil or hydrocarbon. What are the fundamental organic compounds that we get in the oil? To start with, first I will discuss about the alkanes or the paraffins. There are actually different kind of organic matter that we get. We get the paraffins, we get the naphthenes, we get aromatics, we get naphthoaromatics, we get asphaltenes. So all these are different kinds of the organic compounds. Mostly they are carbon and hydrogen rich. Besides these organic compounds, we also get some other trace elements and some other elements such as nitrogen, sulfur, oxygen, what we call the NSO compounds, that is also found. and some trace metals, that also in different kinds of oil we describe the different trace metals. Now first, when I enter into the organic compounds, as I have already mentioned, that there are paraffins. Now what are these paraffins? These are saturated straight chain hydrocarbon which has a formula CnH2n plus 2. So it is basically forming a homologous series, that each unit in the series, that if you add the CH2 you get the next member of the series. That means you get the methane CH4, you add CH2, that is C2H6, that becomes the ethane, then again add CH2, that is C3H8, that becomes the propane, like that it goes. Now this can be either a straight chain or it can be a branch chain. Suppose if the branch chain, it starts from the butane. So you get a butane which has a straight chain, or you can have a branch of that, that is shown in the figure. You can see there is a branch, then you call it a isobutane. So these things, though compositionally a straight chain butane and the isobutane, they are the same, that is C4H10, but if you see the boiling point, they differ. A normal butane that has a boiling point 0.5 degree centigrade, minus 0.5 degree centigrade, whereas in case of a isobutane it has minus 12 degree centigrade. So that means there is a change in the character of the boiling point depending on the what is the structural pattern. Now coming on to the naphthenes, which are also we refer to as the alkenes. Now naphthenes, they are basically the saturated hydrocarbon, and these hydrocarbons, they have a circular structure. We also call it the cycloalkanes. So cycloalkane, you call it naphthenes or you call it alkene. Basically you have a ring structure, 2-3 rings, they may combine together to give a complex molecule, and they normally we get them between C3 to C7, C5 to C7. You normally in the oil you do not get them below C5 and you also do not get them above C7, but their contribution in oil, that may be as high as 50%, so they are abundantly present in it. The composition, what we say, that is the CnH2n. So CnH2n is the general, as I have discussed in alkane, is CnH2n plus 2, here it is CnH2n. So we get the you can get the cyclopentane, you have the cyclohexane. So all these, they are the very good component of any oil. Now coming on to the olefins. Olefins, they are unsaturated and they normally has a double bond. So unsaturated double bond, that is a character of the olefins, and that you can see in the whatever is given in the e-text, you can see that there is a typical double bond which do not allow the total saturation, whereas in case of alkene you had the saturated hydrocarbon where all the carbon atoms, they were satisfied with the attachment of hydrogen. In case of olefins, there is not satisfaction of the all bonds by means of the hydrogen. Now besides this, what is important, that is the aromatics. Now aromatics, they are basically having a benzene ring structure, and it is unsaturated and they have a benzene ring structure. You have a strong double bond as in the benzene ring, what you get. In the figure it is also shown what is the fundamental difference between a cycloparaffin, that is alkene, and that of a aromatic. If you see the cycloparaffin, I can draw it in the board, then it will be much better for you to understand. So that is what you call it a benzene ring, and you get the CnH2n minus 6. That is the formula, whereas this is CnH2n. This is what we call CnH2n plus 2. So this is the fundamental difference, that You call it alkanes, you call it alkenes, you call these olefins, and you call these aromatics. And aromatics is very important, and then you get the mode of the aromatics when you get the heavier hydrocarbons, that the concentration of the aromatics, they become much more, and it is typically identified by its smell, aroma, that is what is called the smell. So aromatics also is important constituent in the heavy fraction of the oil. Now besides these components, what is other more important unit in the oil, that is what is called the NSO compound. NSO, that is nitrogen sulfur oxygen compound, and their concentration in the oil can go up to 3%. Now in what form the sulfur? That it can be free sulfur, and free sulfur that we get in oil from about 0.5% to about 1.5% in the form of thiols or thiophene, that we call the free sulfur. And nitrogen we get in the form of pyridines or idiols, and that we get normally 0.8 to 1.5%. That is the concentration of the nitrogen. And oxygen compound, as you get by the esters, acids, ketones, all these that can go even up to 0.5%. So this is, and together they can maximum go up to the 3%. That is the concentration of this, the NSO compounds, which is also important. The reason is that the presence of sulfur, particularly the sulfur in the we will discuss that how the presence of sulfur that basically affects the boiling point or the different kind of behavior of the oil in the refinery. Now coming on to the difference in the different kind of oil, how we classify the oil. One major way of classifying oil that we discuss, that is what is the very common use of the term, that is called API gravity. Now I define what is the meaning of the API gravity. It is the specific gravity of the oil, that is comparing the oil with respect to water, and this is basically done by American Association of Petroleum Geologists, that is API, American Petroleum Institute. They have devised this criteria to classify the oil into whether it is a light oil, it is a medium oil, it is a heavy oil, or it is a very heavy oil. The criteria is that it is the API gravity, it does not have any unit, but it is expressed in degree. This is what we define it as. As I discussed, there is no unit of API gravity, but it is expressed in degree. API gravity, it says that 141.5 divided by specific gravity minus 131.5. Now the specific gravity of different oil component, that basically is measured at 15.6 degrees centigrade. We measure the specific gravity, and if you follow this, then you say that what is the API gravity of water? The API gravity of water will be 10. And any oil which has a API gravity more than 10, that means it is more lighter than water, and it will float on the water. Or any oil which will have its API gravity that is less than 10, that is heavier than water, and that will sink in the water. So it is a very good criteria that which oil will float on the water and which oil will sink in the water. That criteria is very clear based on the API gravity, whether it is more than 10 and less than 10. Normally the API gravity of oil, that varies from 10 to 70. But what we say that if the API gravity that is more than 31.1 degree, then we call it is a very light and very good quality oil. If it is between 22.3 to 31.1, then you call it a medium oil. Then if it is between the 12 and the 22.3, then you call it a heavy oil, and less than 12 it is a extra heavy oil. So that basically we characterize the oil into the different category, that is light, medium, heavy and extra heavy. judged by the criteria that is what is called API gravity, which is a very important criteria for any classification of the oil. It also helps us that when we go for the refining of the oil, the different components, that is the petrol, diesel, kerosene, then the lubricating oil, all these components that we get out of oil when it goes to refinery. And in the refinery column, actually the oil that gets separated into its different fractions depending on the boiling point. The lower the boiling point, that will rise to the topmost part of the refinery column, and the higher the boiling point, that will come. So you will see that the diesel oil or the fuel oil, they will come to the lower part of the column, whereas the lighter fractions of the oil, that will go to the upper part of the column. So all these, as I have already discussed, that the boiling point again is dependent on the structure. I have already discussed that the difference between butane and the isobutane, that how the boiling point that differs depending on the structure. So what kind of structure of the organic compound and what is their combination that is present in the oil, that basically controls in their refining character, and also the fractions what I will get from that oil. Now see, in this figure an attempt has been made to show you what is the general character of the structure of oil. It is a very complex structure, as you can see, and there are different kind of compounds, as you can see that the nitrogen, sulfur, oxygen, how they remain within the structure that is formed the different kind of organic compounds, the alkane, alkene, and the aromatics. So that kind of structure, this is a very complex structure, that how they make, that an attempt has been made to show you that kind of structure that we get within the oil. This graph, in this graph an attempt has been made to show you the relationship between API gravity and the specific gravity. So different hydrocarbon compounds, where is their position within this curve depending on its API gravity and the different. So as I have already discussed, the API gravity, that is about 141.5 divided by specific gravity minus 131.5. So accordingly you can see that if this specific gravity varies, you can have the different kind of API gravity, and where the different compounds of hydrocarbon they fall within this curve, that is an attempt has been made to show you depending on these two criteria. So this figure, this is a photograph that shown that when you have a very light oil, you can see very light color of oil, and then as you are going to the more lower API value, that the oil color that becomes more dark and it is almost pitch black when you have a very extra heavy oil where you have a very low API gravity value. So once we have discussed the different constituents of oil, then the question comes that what are the materials that give oil. We all know that most of the people believe in the organic theory of the oil, though it is not fully true that there is no inorganic oil. There are some reports of the oil presence in the igneous rocks, but mostly the oil that we get, that is organic in nature. And the organic matter, essentially what we get, there are two broad types, some are autochthonous in nature, some are allochthonous in nature. The autochthonous organic matter, that includes the zooplanktons, the phytoplanktons, bacteria, so algae, so all these they are considered as a autochthonous organic matter, whereas the plant materia, derived plant materia, spores, pollens, that we consider as a allochthonous organic matter. Now these organic matters, they go through the different stages, that is the diagenesis, that is the metagenesis and the catagenesis. So all these stages, where as we discussed, that the diagenesis, there is the main role, that is basically the bacterial role, that in the diagenesis you get the hydrogenation of bond, the disintegration of the complex molecular structure. So all these things that happen in the shallow parts, that we call the diagenesis, whereas that the cracking of organic matter, when you start getting the oil, that what you call the metagenesis, that the cracking of the long chains into the and formation of the smaller chain, that basically lead to the formation of the oil in the metagenesis stage. And in the catagenesis, it is mostly the gas formation, that is the cracking and the formation of the gas, that what we get in the catagenesis part. Now once we know that all these different stages that the organic matter goes through and that result into the different kind of product, then we must know what are the different kinds of organic matter that basically go through these processes. And accordingly, we divide the organic matter into 4 different types, that is the type 1, type 2, type 3 and type 4. The type 1 organic matter which is rich in hydrogen, that means there the hydrogen is to carbon, that ratio that becomes 1 to 1.9, and those are the matters that we consider as a type 1 organic matter, which is the best, which is the one of the best for the oil generation. Here the oxygen is to carbon ratio that basically is about 0.02 to 0.1%, that is the oxygen is to carbon ratio. And this kind of organic matter that mainly formed in the lake sediment, and we call this as a type 1 organic matter. The type 2 organic matter, which is also good in terms of oil, and this has a concentration of hydrogen is to carbon ratio 0.8 to 1.5, and its oxygen is to carbon ratio that becomes that 0.02 to 0.2%. So they also contribute along with the type 1 into the oil generation, and we consider that some of these organic matters is some of the base, suppose the sulfur bearing type 2, they have a low boiling point also. So type 1 and type 2 in terms of its high hydrogen content with respect to carbon content, they are very good in terms of the maturation and the formation of the oil. Now coming on to the type 3 organic matter, here what we get, that we get the increase in the oxygen is to carbon ratio. So that increase in the oxygen is to carbon ratio, so you get the it is about 0.5 to 1%, that is the H is to C ratio, and also the oxygen is to carbon ratio that makes that is 0.03 to 0.3%. So that increase in the oxygen, so they are more prone to the gas, not for the oil. So that formation of the, so type 3 the organic matter, that is more prone to the gas. And the type 4, where the H is to C ratio that comes below 0.5, they essentially is very inert, and we do not get much of the product. Of course, in some cases we may get gas, but they are essentially more inert type. So what the message is that the H is to C ratio and the O is to C ratio that define that how the organic matter will behave when they go to the diagenetic history. If you have the more H is to C ratio, then you will get more chance to form the oil. The more O is to C ratio, those organic matter are more prone to give gas. And the extreme low H is to C ratio definitely will say that the organic matter is inert, or it is originally oxidized, and it has no capability to yield any kind of hydrocarbon. Now coals also are may give hydrocarbon. Now some of the minerals, depending on this hydrogen content, they particularly the cutinite, the sporinite, they behave like a type 1 and type 2 kind of thing, and they are also considered as a good kerogen. But most of the organic matter in the coal, they come into type 3 and type 4, so they are more gas prone, and we do not get much of the oil for the minerals which are present in the coal. Now coming on to that, what is the diagenetic pathway and what we get in this, we will go to the board and draw a diagram which will tell you that what really is the process involved, at what stage what we get. So what this is depth, and we say the percentage of hydrocarbon. Considering the suitable kind of kerogen that is present, then what result as the organic sediments are going to burial, and the sediment containing the potential kerogen which is capable of giving hydrocarbon. Then what are the stages it will go through? It will first go to the diagenetic stage, where the bacterial action is the main process. And what is the result of that bacterial action? That is the liberation of methane, CH4, carbon dioxide, hydrogen sulfide. These gases, that is the biogenic gases, that will be the net result in the diagenetic stage. Now coming on to this, that is the 50 degree to 150 degree window, that we call the metagenetic stage. Here you will get the, initially you may get the heavy oil, then you may get medium oil, and as you attain the more temperature, you start getting the more lighter and lighter oil. So this portion, what we call the oil window, it comes under the metagenetic stage of development, and when the organic matter that starts the beyond 150 degree centigrade. Now there is some variation that what will be the temperature when the metagenetic stage and the catagenetic stage, at what temperature will be the boundary. Now this depend on at what is the age of the rock what you are looking at. The age of the rock, you can have a Cenozoic age of the source rock, you can have a Mesozoic age of the source rock. Then depending on the age, the requirement of temperature changes. Definitely it is a temperature and time effect that basically cause the maturation, or what we call the cooking of the organic matter. So this cooking is a time temperature effect. As you cook rice, you know that how much time and how much temperature. If you put your oven in a very low temperature, you require more time to cook your rice. It is the same. That is, if we give the higher time, that is the Mesozoic time, then you require the relatively lower temperature, whereas a Cenozoic strata that require a higher temperature for the maturation of the rock. So what we see that in case of a Mesozoic strata, that the diagram basically refers to a Mesozoic strata where you get the oil window that is 160 to 150 degree. But if you go to a Cenozoic strata, this requirement, it may go from 90 to 200 degrees centigrade. So that becomes the oil window in a Cenozoic strata. So that is a temperature time effect that basically makes this kind of a situation. Now when as we know that when sediments get deposited, the organic matter that goes into this diagenetic process. Some of these hydrocarbons, they can about 15 to 20% hydrocarbon, I believe that gets formed in the initial stage from the living matter of the organism, and which has a very high N number, that is more than 15. But most of the hydrocarbons that is formed, that forms through this diagenetic history and through the burial. So yes, no, it is not to deny that you cannot get any hydrocarbon to be formed in the shallow depth. You can have some hydrocarbon to be formed by the but that portion is very minimum. The most of the hydrocarbons that is formed, that is to the burial history, and unless that the proper temperature time effect is given, it cannot be formed. Now coming on to, as I have discussed, that the organic matter that goes through burial and it gets matured. This history of maturation of the organic matter with burial, that is best explained by a diagram called Van Crevelen diagram. The Van Crevelen diagram that clearly shows that how the behavior of the different kind of organic matter, type 1, type 2, type 3, type 4. The arrows in the diagram that indicates in which direction it will move as will go to burial and with higher temperature. You can see that how the type 1 and type 2 and what are the products. On this diagram is based on the H is to C and O is to C. Based on that, the different organic matters are plotted, and their movement according to the maturation that is being shown. Along with that, what is given, that is the vitrinite reflectance data that has been plotted, so that it can act as a proxy to understand the degree of maturation of the organic matter. So the reduction, generally what is seen, that the reduction of a hydrogen from the organic matter, that gives your hydrocarbon, that is the oil. The reduction of oxygen from the organic matter, that gives the gas, and most of the hydrocarbon that is formed when you have the vitrinite reflectance, that varies between 0.5 to 1.3. And anything of vitrinite reflectance, when we see more than 2, that is the inert organic matter. So Van Crevelen diagram is a very good process to know that what stage of maturation a organic matter has gone through, how we interpret that the maturation of the organic matter, and that everything is dependent on the H by C and the O by C ratio of the organic matter. So if I summarize whatever we have discussed that what is the constitution of a hydrocarbon. There are different organic compounds, the alkanes, alkenes, then olefins, aromatics. All these are the organic compounds that make the hydrocarbon in the complex structure, and there are some nitrogen, sulfur, oxygen up to 3% that can be present within it. It is a complex structure, and that in the process of maturation, the different kind of organic matter, depending on whether it is a autochthonous and the allochthonous, they are classified depending on their hydrogen carbon and oxygen carbon ratio, and they go through burial, and the burial history, the diagenesis, metagenesis and catagenesis, through this burial history they go matured, and that basically forms the oil window which gives the oil to us. So the compositionally what is oil, and what kind of organic matter can give oil, and what physico-chemical condition where the oil is formed, this was the aim of discussion in this module. I believe that you all have enjoyed this discussion, that how the organic matter and what type of organic matter give oil and at what condition, and this will encourage you to further read from the different references given in the e-text along with this. And with this I end this module, and thank you.